Today we're going to finish our notes on completing the square. So you can also put today's date, April 28th, at the top of the note packet. And again, this is what the notes looked like yesterday. Yesterday we examined completing the square using rational roots. Today we're going to examine what happens when you get irrational roots. So just to refresh your memory, if you have an irrational number, that means we have the square root of a number that is not a perfect square. So we'll never be able to obtain two identical factors that will create it. What we can do is leave it as a square root radical, which is a simplified answer, and it's an exact answer, and this is what I prefer. Or we can come up with a decimal approximation, but we only do that if they specifically ask for it to the nearest tenths or hundredths. If they don't specify the decimal place, that means they're trying to tell you that it should be left as a square root radical. So, picking up with example number 5 in our packet, my quadratic equation is already in standard form. Remember, we separate into two sides. We have the quadratic and linear term on the left. The constant is moved to the right. So I'm going to add 18 to both sides. And when I do that, I'm going to make space now for my perfect square trinomial. We look at the term of 14. We're going to split it in half and then square it. So we're going to use 7 squared to fill in our blanks. And that's 49. On the left, we have two identical factors of x plus 7. And then on the right, we combine our constants to get 67. We're going to square root both sides. On the left, I'll be simply left with x plus 7. And on the right, I have positive and negative square root of 67. At this point, you should determine if you can simplify radical 67. Are there squares that we can break this down into? I'm going to first subtract 7. And then after checking my iPad, I know that there are no perfect squares that can be removed from 67. In yesterday's lesson, we separated this now into two distinct roots. What I'm going to ask you to do is put the negative 7 first, and then follow it with the positive and negative radical 67. All we have to do is separate this into two solutions or two roots. So when I write the solution set, I'll have negative 7 plus the square root of 67 and negative 7 minus the square root of 67. And you leave it just like this. In number 6, the quadratic equation is already in standard form. So I'm going to add 30 so that I can move that constant to the right-hand side. And I'm also going to make space for my perfect square trinomial. Half of 16 will be 8, and then we'll square the 8, and we're going to fill in our blanks with 64. So again, on the left, we have two identical factors of x plus 8. My constants combine to 82. We're going to square root both sides, and I'm going to check right now on the iPad, but the square root of 82 cannot be simplified, so we'll leave it as positive and negative. And then to get x alone, we'll subtract 8 from both sides. Again, we're going to put the negative 8 in front. So my roots are negative 8 plus or minus the square root of 82. And in the final step, we separate in the solution set, negative 8 plus the square root of 82 and negative 8 minus the square root of 82. Number 7 is also in standard form, so I'm going to subtract 4 to separate into two distinct sides. We're going to look at half of negative 6, which is negative 3. We'll square it and fill in and balance the equation with 9. My two identical factors are x minus 3, and the constant simplify to 5. We'll square root both sides. And 5 is a very simple number. In fact, it's prime. So we won't be able to simplify that any further. I'm going to add 3 to both sides. And then I'm going to state my roots with positive 3 first. So x equals 3 plus or minus the square root of 5. And again, for the solution set, I will separate this into two distinct solutions. And this problem's all set. In example number 8, the equation's in standard form. I am going to subtract 83 to put it on the right-hand side. And we'll make room for our new trinomial. So half of 20 is positive 10. Filling in the blanks with 100. Two identical factors, and my constants simplify to 17. Square root both sides. 17 is also prime, so there'll be no factors that won't be simplified. We're going to simply subtract 10 from both sides, and then when I set up the final answer, I'm going to put the negative 10 first, so x equals negative 10 plus or minus the square root of 17. And then we're going to go ahead and separate that into two distinct roots. For our last example, number 10, it does say that you can use decimals. What I'm going to do is I'm going to add 4x to both sides, but I'm also going to add 16 to both sides. So the constants are going right, the quadratic and linear terms are going left. So we'll end up with negative 2x and then a constant of 28. I've left room to complete the square. Half of negative 2 is negative 1, and when I square it, we'll fill in our blanks with positive 1. We have our two identical factors and 29 on the right-hand side. Square root. 29 is also prime, so we're lucky there. There's no simplification. We're going to add 1 to both sides. And when I write up the solution sets, because they told me to put it in the form of a decimal, I have the positive square root of 29 and then plus 1. So it gives me 6.38516. I'm also going to use the negative square root of 29 plus 1, and I get an answer of negative 4.38516. They will be specific on how to round this. I rounded both to the nearest hundredths, so my solution set is negative 4.39 and positive 6.39. But again, we're only going to convert to decimals if the directions specifically ask for it. Otherwise, we'll leave it in the simplest square root radical. Tonight's homework is number 106. At the top, you'll see it says completing the square irrational roots. You can show me all your work right in the white space. If you have any questions, please make sure you contact me. Otherwise, have a great day.